By the summer of 1943, RAF Fighter Command found itself confronting a crisis that no amount of optimism could disguise, for the Luftwaffe was evolving faster than British planners had anticipated, and the formidable new German fighter variants arriving over occupied Europe posed fresh questions that the aging Spitfires and troubled Typhoons could no longer answer. Reports arriving from frontline squadrons referenced a new menace with increasing anxiety: the Focke-Wulf long-nosed Dora, a machine that represented the culmination of German wartime engineering. Powered by the Junkers Jumo 213 inline engine, the Dora could climb at astonishing rates and run down nearly anything the RAF still had in widespread service. At altitude, it became a predator, and even the beloved Spitfire, an aircraft that had come to symbolize Britain's defiance, was being pushed to its structural and aerodynamic limits. The Spitfire Mark IX could outturn the Dora in the classic dogfighting sense, but the Germans had learned never to turn with British fighters. Instead, they dove away, climbed at brutal angles, and blasted forward on straight-line extensions that left Merlin-powered pursuers shuddering at red-line manifold pressures. Fighter Command knew that something faster, tougher, and more brutally powerful would be needed. Yet speed was only one of the Air Ministry's growing concerns, because intelligence reports filtering in from occupied Europe hinted at a new threat that seemed almost fantastical: the development of pilotless aircraft, flying bombs that could be launched at London without risking a single Luftwaffe aircrew. These rumors, initially dismissed as exaggerations, soon took form in reconnaissance photographs. The Germans were preparing to unleash the V-1, a weapon British civilians would grimly nickname the Doodlebug, and intercepting such a machine would require fighters capable of speeds exceeding 400 miles per hour in level flight. No current RAF aircraft could reliably achieve that performance margin long enough to guarantee interception. The Typhoon, brutal and powerful, possessed raw strength thanks to its Napier Sabre engine, but it suffered from severe compressibility problems at high speed. Its thick wing created colossal drag, imposing a hard aerodynamic ceiling that pilots could not push through. Worse still, the Typhoon carried the stigma of early structural failures, particularly tail separations, that had killed pilots without warning. Though largely corrected by 1943, the shadow of unreliability still lingered. Fighter Command needed something fundamentally different: the Typhoon's power without its vices, the Spitfire's agility with far greater speed, a miracle of aluminum and resolve. Fortunately, one man had already been working towards such a solution. At Hawker's design offices in Kingston upon Thames, Sir Sydney Camm, the architect of the Hurricane and one of Britain's finest aeronautical minds, had been wrestling with the Typhoon's flaws since its introduction. He knew precisely what held the Typhoon back: the wing. It was too thick, generating too much drag and compromising high-speed handling. Camm believed that a thinner, more elegant wing would unlock the Sabre's full potential, translating its ferocious horsepower into true velocity rather than turbulence. But designing such a wing posed daunting engineering challenges. It still had to house landing gear for 20mm Hispano cannons, ammunition, and fuel. Every millimeter had to be reconsidered. By late 1943, Camm's team had produced drawings of the Typhoon II, the aircraft that would soon be renamed the Tempest. It promised everything Fighter Command desperately needed. Whether it could deliver those promises in combat was another matter entirely. Across the Channel, German fighter production was accelerating, and failure would mean more British pilots dying in aircraft that could no longer compete. Camm carried the memory of the Hurricane's shortcomings with him. Though heroic during the Battle of Britain, it had been inferior in raw performance to the Messerschmitt 109. Tactics and courage, not engineering, had carried RAF pilots through. Camm refused to let that happen again. The Tempest's redesign began with its revolutionary wing, where the Typhoon used a thickness-to-chord ratio of around 18%. The Tempest's root ratio dropped to 14.5%, tapering further toward the tip. This seemingly small adjustment carried immense consequences. The reduced internal volume forced engineers to reinvent nearly every internal component. The leading edge received special shaping to delay compressibility buffeting, violent shaking that Typhoon pilots knew all too well during hard dives. Wind tunnel tests at the Royal Aircraft Establishment confirmed that the new contours performed brilliantly above 450 miles per hour. Drag dropped. Control authority increased. The path forward was clear. Camm then tackled the Typhoon's notorious chin radiator, which hung beneath the nose like a clumsy afterthought, generating drag and ruining airflow. German fighters had embraced annular radiator systems that wrapped around the engine. Camm adopted a different but equally elegant solution, embedding the radiator in the Tempest's wing leading edge, routing airflow through carefully designed ducts. The result was a sleeker nose, improved cooling, and dramatically reduced drag. The entire aircraft began to take on a predatory, streamlined appearance. With more power came new stresses. The Napier Sabre engine, a 24-cylinder H-configuration monster, produced immense vibration. Early Typhoons suffered cracked mounts, shaken instruments, and premature fatigue. Camm's engineers designed new engine mounts with rubber bushings tuned to absorb specific frequencies, giving the Tempest a surprisingly smooth feel despite its immense power. The fuselage grew longer for improved stability and fuel capacity, while the tail was redesigned for greater control authority at high speeds. By spring 1943, the first prototypes were taking shape. On September 2, 1943, test pilot Philip Lucas took the first Tempest aloft for a cautious 15-minute flight. Upon landing, he reported with barely concealed excitement that the aircraft handled beautifully, crisp and stable, with none of the Typhoon's infamous quirks. For the first time, Camm knew he had created something extraordinary. Yet the heart of the beast, the Napier Sabre engine, remained both miracle and nightmare. Its sleeve valve design allowed extraordinary airflow and compression, enabling power outputs above 2,000 horsepower, but maintenance demands were legendary. The slightest manufacturing imperfection could cause catastrophic failure. Ground crews respected and feared it in equal measure. Starting procedures were delicate. Oil could pool in cylinders, causing hydraulic lock capable of bending connecting rods instantly. But when the Sabre ran properly, nothing else in Britain's arsenal could touch it. The Tempest could exceed 435 miles per hour in level flight, and pilots occasionally reported speeds approaching 450 miles per hour, claims later validated in post-war tests. It became the fastest piston-engine aircraft to see substantial combat service with the RAF. Fuel consumption was enormous. At combat power, a Tempest could drink 150 gallons an hour, limiting patrol time to around 90 minutes. Ground controllers had to carefully manage sortie ranges. The four-bladed de Havilland propeller produced a distinctive, thunderous roar that German pilots later recalled hearing from miles away. It became part of the aircraft's legend. By April 1944, the first Tempest V squadrons stood ready. Wing Commander Roland Beamont, a veteran Typhoon ace, took command of 150 Wing at RAF Newchich in Kent. Conditions were primitive, steel mesh runways, tents, mud, but the strategic location placed the Tempests directly in the path of the imminent V-1 offensive. When the first V-1S streaked across the Channel on June 13, 1944, the race began. The Tempest, finally unleashed, became Britain's most effective V-1 interceptor. Its speed allowed it to overtake the 400 miles per hour flying bombs quickly, while its stability made precise gunnery possible. But interception remained perilous. Closing to firing range meant risking destruction from the V-1's 1-ton explosive payload. Pilots soon developed additional methods, including the famous wing tipping maneuver, nudging a V-1 off gyroscopic balance and sending it into an uncontrolled dive. This required extraordinary precision. A mistake meant collision and death. By August, 150 wing had destroyed more than 600 V-1s, accounting for nearly one-third of all fighter kills during the campaign. Individual Tempest aces achieved astonishing tallies. Squadron leader Joseph Barry claimed 60 V-1s before his death. Richard Van Lierde scored 44. The Tempest had proven itself beyond dispute. Its legend grew across the Channel as Luftwaffe pilots encountered it for the first time. German intelligence officers struggled to identify the new machine. Reports described a British fighter faster than any known Allied piston aircraft. Some pilots insisted it must be an early jet. Its long nose, thin wings, and blistering acceleration contributed to the confusion. For the first time, late-war German fighters such as the FW-190D and Bf-109G found themselves at a disadvantage in sheer speed. German pilots accustomed to escaping by diving away discovered, to their shock, that the Tempest could follow and catch them. This psychological impact was profound. Captured documents reveal growing respect and genuine anxiety regarding the Tempest's presence. But the Tempest's role shifted again as the V-1 threat faded. By late 1944, Tempest squadrons moved to the continent, tasked with hunting the Luftwaffe's new secret weapon, the Messerschmitt Me-262 jet. In level flight, no propeller fighter could hope to catch the 540 miles per hour German jet, but Beamont and his pilots developed tactics exploiting the 262's weaknesses, its slow throttle response, long landing approach, and vulnerability at low speed. Tempests patrolled near known 262 bases, ambushing jets during takeoff or landing. Beamont himself downed one this way. By war's end, Tempest units had destroyed more than 30 Me-262s, an extraordinary feat given the technological gulf between piston and jet propulsion. The Tempest also became a feared ground attack platform, tearing across northern Germany, destroying trains, convoys, and airfields. Its 4 Hispano cannons and ability to carry bombs and rockets made it one of the most devastating low-level attackers of the war. These missions carried immense danger from light flak and casualties mounted, but the aircraft's speed often saved pilots where slower machines would have been lost. Behind every sortie stood remarkable pilots: Pierre Clostermann, David Fairbanks, Roland Beamont, men who pushed the Tempest to its limits and documented its triumphs. Clostermann's memoir The Big Show immortalized the Tempest's ferocity and the surreal clarity of high-speed combat. Fairbanks, an American in the RCAF, used meticulous tactical thinking to claim 11 victories, including several jets. Beamont's leadership shaped the Tempest's combat culture, and his post-war test piloting career influenced British aviation for decades. When victory arrived in May 1945, the Tempest stood acknowledged as one of the finest piston-engine fighters ever built. It had destroyed more V-1s than any other fighter, hunted German jets, dominated low-altitude air combat, and provided tactical flexibility unmatched by most Allied aircraft. Post-war analysis confirmed what pilots already knew. The Tempest V was the fastest operational piston fighter of the war that saw significant action. Its legacy extended into the post-war years with the Tempest II and the famous Hawker Sea Fury, which continued the lineage and even achieved a jet kill in Korea. Today, preserved Tempests in museums and private collections testify to its size, beauty, and lethal capability. Aviation historians routinely rank it among the apex designs of the propeller age, a machine so advanced that German pilots in 1944 genuinely questioned whether it could still be a piston aircraft at all. In many ways, the Tempest embodied the closing chapter of an era, the ultimate refinement of a design philosophy that stretched back through the hurricane. As jet engines rapidly rendered piston fighters obsolete, the Tempest stood as proof of what brilliance, discipline, and urgent necessity could create. It was not merely a warplane. It was a statement of engineering mastery, of tactical ingenuity, and of the will to survive the darkest years of aerial warfare.